that snake looking thing. Okay, so the quadratic parent function. We have, I'm just going to do it for you just for the sake of time. When we plug in 0 squared, we get 0. We get 0. When we plug in negative 1 squared, we get 1. Negative 1 times negative 1 is 1. When we plug in negative 2 times negative 2, we get a positive 4, and that mirrors on that side. Okay? Now let's go ahead and graph it just so that we know the general form of what it looks like. Oh, sorry. So I have 0, 0 here, and I'm going to go ahead and graph the table. Write 2 up 1, 2, 3, 4, and it mirrors on this side. Give you a second. Some of you are still finding your notes. Pink packet. Does that work?
The light's not. Isn't there like a light on it?
None of them have it on. It might be unplugged.
Out there. It wasn't pushed over there yet. Are they on?
Yeah.
I just put that there.
Okay, so this is how we learned it on chapter 4. Now I'm going to talk to you about this thing called a pattern. So yes, you can go in your graphing calculator every single time, graph it, get your points. That's fine. But there is a pattern that happens here. We go right 1, up 1, right? Because 1 squared is 1. We go right 2, up 4, and that happens every time. Now this is supposed to be left 1, up. So go ahead and cross that out and put up. I made an error on my notes. So left 1, up 1, left 2, up 4. That's what we just did. And we can use that for the rest of these x squared functions to help us out. So I'm not even going to do the cubic yet. I'm going to do all the quadratics to make sure that we understand. Okay, so I'm going to go to number 7. We had transformations in chapter 4. Left, right, up, down, stretching, compressing, reflecting. We did that on the prereq sheet. That's why I had you guys do that. Does anyone remember what this 3 represents? Would that be left or right 3? Right 3. So I have right 3. And then what about this? Hold on, something just happened. What about this negative 4? Are we going to be going up or down 4? Down. So I have down 4. That now is going to be your vertex. So if I go right 3, down 4, my vertex is going to be 3 comma negative 4 because I went down 4. And then we use that pattern to help us out. So the pattern I just taught you, we can use it. Now, when we first learned this in chapter 4, we didn't do it that way where we did the pattern. We just went to the graphing calculator, got some points. It took a long time. Once you get used to the pattern, I'm telling you, you're going to fly by. So I'm going to go ahead and plot my vertex. 1, 2, 3, down 1, 2, 3, 4. Now for the first time that we do this, I don't want you to write anything down. I just want you to watch. Now remember, this is what my pattern is. I'm going to write, actually I do want you to write this part down. I'm going to write the pattern out just so that we have it. No, I'm going to write down here. Right 1, up 1, right 2, up 4, left 1, hold on, up 4, left 1, up 1, left 2, up 4. That's the pattern. I'm telling you, once you have that pattern down, this is super easy. Again, you can go to your graphing calculator and graph it if you're lazy, but it will take you actually more time to do that than for you just to know this pattern. Okay, so from that point, from that green point that we just drew in, we're going to use that pattern. Here we go. Right 1, up 1. Right 1, 2, up 1, 2, 3, 4. There we go. Do it again. From the green point, left 1, up 1. From the green point, left 1, 2, up 1, 2, 3, 4, and we're done. It is a lot easier to actually just know the pattern than for you to go in your calculator, type it in, make sure it's right, go to your table, get some points. Okay, this will take you a lot less time. Okay, but if you get stuck on the test and you don't remember the pattern or you don't have your note card, get your graphing calculator out and you would get the same answer as me. Do you have questions on that one? Okay. All right, now I'm going to teach you the cubic one. So that was the quadratic pattern. Again, we learned this all already. It's just you're learning about this pattern now. So here, cubic, bless you. 0 cubed is 0, right? Okay, so I'm going to plot that, 0, 0. Then I have negative 1 to the third power. That's negative 1 times negative 1 times negative 1, which is negative 1. Negative 2 times negative 2 times negative 2 is negative 8. Because 2 times 2 is 4, 4 times 2 is 8. Now that mirrors over to the other side. 1 cubed is 1, 2 cubed is 8. And again, you can go in your calculator right now and you can type in 2 to the third power, and that's what you would have gotten. All right, let's plot it. So then this is going to be here, left 2, down 1, 2, 3, 4, 5, 6, 7, 8, something like that. And these mirror over. Mine's kind of lagging, so bear with me. So just like what this table is, that's your pattern. So again, getting used to this pattern. Once you have these two patterns memorized, quote unquote, you'll be able to fly through it because on the back, it's the same pattern, just switch. Okay, so I went right 1, up 1, right 8, up 2, left 1, up, down 1, and then left 8, down 2. And the reason why that pattern works, again, is because, oh my God, I just gave you the wrong, I was thinking about the back page. Erase these two. This is 2, this is 8, and then 2 and 8. Here's why, again, because 2 to the third power is 8. That's why the pattern is that way. Sometimes I get them mixed up. Okay, now let's use what we just learned to help us out on the problem we're going to do below, 7b. Now again, the biggest thing first is to realize that you're cubic. Because a lot of you, what I've noticed in the past is that people will use the pattern for squared, but we're doing cube. What is the, well, let's first talk about the transformations. What does this positive 2 mean we're doing? Good. Left 2. What does this positive 1 mean we're doing? Up 1. If I go left 2, my vertex is at negative 2 and up 1. Or you can just plot it. Like if you go left 2, up 1, then you can plot it and say, oh, my point's negative 2, 1, instead of thinking about it. Now, because we didn't stretch or compress or do anything, we can just do the pattern. So my pattern is, I'm just going to write it out until we memorize it. Right 1, up 1. Right 2, up 8. Now we just do the opposite, because really that's the only part you have to memorize, and then it's switched. Left 1, down 1. Left 2, down 8. You can see that these kind of mirror each other. It's hot in here. Okay, from the red point, that's where we use the pattern. So from the red point, right 1, up 1. From the red point, right 2, up 1, 2, 3, 4, 5, 6, 7. It's like right there. It's not really on the graph. From the red point, we go left 1, down 1. From the red point, we go left 2, down 1, 2, 3, 4, 5, 6, 7, 8. Okay, like I said, if you got stuck or this is like, whoa, patterns are too much for me. I know some people that just love patterns, like patterns are their thing. Okay, if it's too much for you, then you can go to your graphing calculator, type this in, and get these points. It will take you longer, and you'll still have to graph the points correctly. That's why I try to teach you the patterns part. You have questions on that one? Again, from our vertex, that's why I put it underneath it. We go right 1, up 1. From our vertex, we go right 2, up 8. That pattern will never change. You have questions? Yeah.
Like, how do you determine, like, you have to go up 8 or 4 or whatever?
So the reason why we had those is because in our graph, if you plug it in, hold on. Okay. If I plug in 1, I get back 1. If I plug in 2, I get back 8.
Yeah.
So that's the pattern. Because 2 times 2 is 4, and 4 times 2 is 8. So it's the cubic that's determining that. So good question. Okay. So now I'm actually going to have you flip to the back page because that's really the most important. Because this is all from last semester. Like that, we've already done it. We just didn't do the pattern. That's the only difference. We did the transformations and we graphed it before, but we just never did the pattern. So now I'm going to teach you the opposite. And the reason why if you memorize one, you can memorize the other. So a square root. Let's talk about this. What is the square root when I plug in 0? What's the square root of 0? 0. What's the square root of 1? 1. What's the square root of 4? 2. Okay, so that's our pattern. We go right 1, up 1, right 4, up 2. It's because all I do, again, is I took this 1 and I plugged it in. So this is why I'm proving this to you, and then after I prove it, you can just know it. You can just memorize it or or have that in the back of your head. Okay, so let's go ahead and graph it. So 0, 0. I'll zoom in here. 1, 1. And right 1, 2, 3, 4. Up 1, 2. And there we go. That's what a square root looks like, which you guys had experience looking at least. You've seen this graph before because we just did it in the past couple of days. We just didn't do anything with it. Okay? So that's now our new pattern. So again, this is a square root. That's huge. And maybe like circle it, highlight it. And if you notice from the first page, that's the same thing. It just switched. If you look at it, it normally was right 2 up 4, and now we're going the opposite, right 4 up 2. Same thing with cubic. So let's talk about this. What is the cube root of 0? 0. What is the cube root of 1? 1. What is the cube root of negative 1? Negative 1. What is the cube root of 8? 2. Here's why. 2 times 2 is 4. 4 times 2 is 8. So that's why this is 2. Well, with the negative, we just kind of attach that on. You can put that in your calculator, but here now take a look. I know some of you are still writing, so I'll wait a second. The cool part about this is if you memorize this one, you have the cubic memorized, and I'll show you that. So if I go all the way back up to the beginning of what we just did, this pattern is the same thing but switched. And why is that? It's because they're inverses of each other like we've been learning the past couple days. Okay, so now, again, the pattern. Same thing that we just did. Ooh, it's really lagging, I'm sorry. The same thing that we just did. We went right 1, up 1, right 8, up 2 now. So remember last time it was 2, 8, now we switched it. Same thing, left 1, up 1, left 8, down 2. Again, you could get you could just go to the graphing calculator and get your table and call it a day. That's fine. However, if you want to be efficient, it's faster this way once you have it memorized. Okay, so let's graph it. 0, 0. Remember, we go right 1, up 1, right 1, 2, 3, 4, 5, 6, 7, 8, up 1, 2. Same thing on the other side. And then down 2. And it looks now like this. And remember, we saw this last week. We just didn't really talk about what it was. So this is a cube root function. Remember, there's like a little 3 right there in your radical. Okay? They're inverses of, remember when we were doing the solving part last week where like you had to solve for, the x squared, the inverse was square root. The inverse of cube rooting is cubing. So like the first page and the second page are inverses of each other. All right, let's practice this. So let's talk about this. It says graph each function, describe the transformations, identify the domain and range. Pay close attention to the type of root. So first you need to establish what kind of radical are we working with. So here we're talking about a square root, whereas the one below it is a cube root. So you can see the difference. This is a cube root, and this is a square root. Technically there's a 2 inside there. But let's talk about the transformations. What does this 5 mean? Good, left 5. I'm happy that you guys remember this from like every chapter we've done in this year, maybe besides a couple. What does a 2 mean? Down 2. So the very first step when you graph these by yourself without a calculator is to graph that. So we're going to go left 5, down 2. Left 1, 2, 3, 4, 5, down 1, 2. That is like my point of inflection. That's my vertex point. From there, you use your pattern. And that's what's cool about it. Once you get used to the pattern, you use it. So I'm going to write off to the side the pattern until you get used to it. So the pattern is right 1, up 1. Then the pattern is right 4, up 2. And here's why again. The square root of 4 is 2. That's why it's the pattern. The square root of 4 is 2. That's why it's the pattern. So from the purple point, we go right 1, up 1 in pink. Then we go from the purple point, right 1, 2, 3, 4, up 1, 2, and that's our graph. Boom. And here's the big thing. Having general knowledge of what the graph should look like is huge. Because if I go back to our original graph, here's our parent function. It looks like that. Okay, it doesn't look like a different type of function here. Domain and range, here we go. From the point that you wrote out, When you go left 5, down 2, that's what you're using for your domain and range. Because this is x is equal to negative 5 here, right? Because we went left 5. And our y value is equal to negative 2 because we went down 2. So that's the two values you're going to use for domain and range. Domain, am I going to use the negative 5 or the negative 2? The negative 5 to infinity. And then the other one I will use the y. So once you find this point right here, that helps you with the domain and range. And that's the left, right, up, down, that kind of thing. Okay, I know it's different, it's weird, and like I said, if you went to your graphing calculator right now and you typed in that graph, that's what you would get. And that's okay. If you feel like that's more comfortable for you, you don't like the pattern, then do it. The pattern is just faster and easier, and it's nice to recognize. Okay, let's look at this next one. Okay, this one's a little bit different. Let's talk about why. What does this 2 in front mean? This was a stretch or a compress. What do you think? Yeah, stretch by 2. And again, I'm sorry, it's lagging on me. Okay, so that means we didn't move left and we didn't move right. So our initial point is going to be at 0, 0. So if we move left or right, nothing, we're going to be right at the 0. And then we use our pattern. And let's write our pattern out off to the side. I go right 1, up 1, right 4, up 2. And the more you write it, you're going to be shocked on how much you start to memorize it. But if we stretch by 2, let's talk about that. If your graph stretched by 2, would you multiply the right or the up by 2 if you're stretching by 2? What do you think? So, what'd you say? The up part. So what I'm going to do for you guys is just to kind of get you used to this, is really all you would do is you would multiply this guy by, oh sorry, it's just a positive 2, by a 2. So instead of going right 1, we would go up 1, we'd go up 2. Instead of going up 2, you'd go up 4. So the only time that your pattern changes is if you stretch or compress or reflect. Okay, up and down doesn't do anything. So here we go. Right 1, up 1, 2 now. Right 1, 2, 3, 4, up 1, 2, 3, 4. And there we go. Again, let me say it again. If that was confusing for you, like sometimes I have kids do the pattern for ones that we just did over here for letter A. And then when they get to the ones that are stretching, they're like, it's too much work for me. Let me use my calculator. That's fine. I would recommend at least trying to do a couple without your calculator. But I'm going to show you always how to do it without one, and then you can choose to use the calculator or not, because you know how to use that calculator more than I do, I think. So the domain is going to be 0 to infinity because we start at 0. And same thing with the y, 0 to infinity. The only time that changes if you go up left or right. If it helps you to write it out, write x equals 0 and y equals 0 for that red point. That point that you start at is at 0, 0. It helps you. Let's do this one more time. Again, you will get better at it, I promise. You just got to take your time. The biggest things I really need you to remember is the transformations. You can't use the calculator to figure out your transformations. You have to use your brain. Okay, there's a lot of distraction right now. We got 3 computers and we got 1 phone. That's literally only 3 people then out of 4. 3 out of 7 are participating in here. Okay, this negative, what does it mean? Remember what happened? It reflected. Very good. It's a word that people don't use often. You reflected over the x-axis. So I'm going to put over the x-axis because sometimes it might be y. We won't see y a lot, but we're going to reflect it over the x. So where do I start? Did I move left or right anything? No, so I always start at 0, 0 then. You start at 0, 0 whenever you don't move left or right at all. So that pink point. Here we go. I'm going to write my pattern out. Right 1, up 1. Right 4, up 2. Just like we did with stretching. The only thing that's going to change, well, when you reflect over, instead of going up, you're going to go where? Down. So this is really just going to change to down 1 now and down 2. Whenever you have a reflection, it changes it from up to down. That's all. So here we go in purple. right 1, instead of going up, I'm going to go down. Down 1. Right 1, 2, 3, 4, down 1, 2. And it looks like this. Again, you're more than welcome to put that on in your calculator and get it. I'm not going to make you memorize it if you don't want to. But for the notes, I'm going to write it all out. Okay, your domain starts at 0 and it goes on forever. Let's talk about this other one, though. Is that arrow going to be going down to negative infinity or going up to positive infinity? Negative. Okay, so I'm going to be going from negative infinity to 0 now because it's going down and not going up. That's the difference. So I'm going from negative infinity to y equals 0 here. Negative infinity, and I'm stopping at 0. You have questions on that? Okay. Let's talk about these other ones now. Take a breather. These ones are all cube roots. The very first step is for you to identify what root you're in. So I'm cube root. So my pattern's going to be right 1, up 1, right 8, up 2 now. Okay, so once you realize what you're in, you can use your pattern. But let's talk about the transformations. What does this negative 2 mean? Right 2. What does this negative 3 mean? Down 3. Very good. So that's where your point's at. Let's graph that. Right 2, down 1, 2, 3. That's my point. That's huge. That point is like the main point. Here's why. Even if you're using your graphing calculator, I get the question of, well, what points do I choose? You choose points around this. You would go like 2 to the right and 2 to the left of it if you're going to choose it using your graphing calculator. Okay? So the pattern, I'm going to write off to the side. Right 1, up 1. Right 8, up 2. Now it's the same thing, but left and down. So left 1, down 1, left 8, down 2. And again, I know it's a lot to like remember, but after a while, you're going to be shocked on how much you remember those patterns. So from that blue point, I'm going to go right 1, up 1, and then right 1, 2, 3, 4, 5, 6, 7, 8. It's like way off the graph. Up 1, 2 is like right there. Same thing, left 1, 2, 1, down 1, left 1, 2, 3, 4, 5, 6, 7, 8, down 1, 2. And there's my graph. Here is the best part about these ones. What's the domain and range of anything that has an odd power? Any remember? Domain and range. Does it go forever left? Does it go forever right? Yeah, so it's all real numbers. That happens for every single function that has an odd power. So for example, this had a 3. That means it's all real numbers. Above, it was a square root, and square root's even. A 2 is even, and that's why it was restricted. Do you have questions on that one? Okay. Now, for these next two, I'm going to show you the alternate way. Just in case you're like, this is too much, I want to use my graphing calculator. So get out your graphing calculator, and I will show you the other option. Okay, let's first, before we do that though, talk about the transformations, because that's what you want to do first to get your point. So here, what does this 1/2 mean? Stretch or compress? Compress. So compress by 1/2. What does the +1 mean? Careful. It's not inside, it's outside. So are we going to be moving up or down? Up 1. So the only thing that I can do is go up 1. You can't really compress by 1/2. Okay, so I'm going to go up 1 here. Okay, that's going to be like the points that you want to start working with. So let's go to y equals. And let's clear it out. Clear, clear, clear. You probably can't see that very well. Okay, here's how you get that cube root. Press, well, let's do the 1/2 first. 1 divided by 2. Sorry. Then you press math, and you see it right there, number 4. Okay, number 4 will get you the cube root of x. But if you look here, you're kind of stuck inside this radical now. The only way to get out of the radical in your calculator is to go right and press +1. So it should look like that. Press graph. And you can see here that it looks like that. And I'd be happy if you go ahead and you just get those points. Get to your table, second table. And look, remember, I wanted you to start at 0, 1. Look, and that's what we wrote over here. We started at 0, 1, like we said. We'll get the points above it and below it. So -1.5. So -1.5. And then you had 1.5. 1.5. And we can just sketch from there. It doesn't really matter. So if you want to use your graphing calculator, which you just saw, is kind of a little bit harder to like get everything going and getting it right in there. What's the domain and range of all of these types of functions? Yeah, negative to positive. Okay. All right. We're going to stop there. Make a note for yourself somewhere 1 through 3. The pattern is square root pattern. Maybe I'll do that. Is right 1, up 1, right 4, up 2. Because the square root of 4 is 2. That's why it's right 4, up 2. That's all for 1 through 3. And then for 4 through 6, we have the cube root. And the pattern is right 1, up 1, right 8, up 2. Because the cube root of 8 is 2. And then it switches. Left 1, down 1, left 8, down 2. So I wrote those patterns out for you, but I would recommend writing it out every single time because then that's the only way for you to memorize. It's really not hard to memorize 2 things. Right 1, up 1 is everything. Every pattern that you use for functions is right 1, up 1. Okay, that's easy. The second part is right 8, up 2. Well, then it just switches into left and down. So 8, 2, it's not that hard to memorize. Right 8, up 2. Then it switches to left 8, down 2. It just switches the position of it. Okay? Again, it's great if you can do it without one, but if you need it, use your graphing calculator. The biggest part of today that I need you to understand is the transformations in the domain and range. However you get the graph is your choice. Okay, if you choose to graph it on your calculator or use the pattern, that's fine. The big parts are the transformations in the domain and range. How you get the graph is your choice. I don't care either way. You won't have to graph on the SAT. The graph will either be given to you or you can use your calculator. So I wouldn't make you memorize patterns if you don't want to. But I think most of you will use the patterns because they're easy. It's harder to type. Sometimes you just make a little error in your calculator and that's why you get it wrong. That's why I teach you the patterns because you should be able to do it. If you want to check your answers, you're more than welcome to. Still got 10 minutes. If you have questions, let me know. The only ones that are affected by the pattern are number 3 and number 4. Number 3 and 4, you'd have to adjust your pattern. 3 and 4. Let's talk about number 3. This -2, because it's all the way out in front, means the pattern is changing. The only time their pattern doesn't change if there's nothing in front of this radical sign. So that means right here, I kind of wrote out for you. Right 1, up 1 is now becoming right 1, because you have to multiply by -2, down 2, right? Because if you do 1 times -2, you get -2, which is down 2. So this is becoming down 2 now. If you multiply this by -2, because that's what that -2 does all the way out in front, 2 times -2 is a -4. So we're going down 4 instead. So that's the only time your pattern changes, is if you have a number all the way out in front. In this situation we did. Okay, there was a number all the way out in front like that. Whereas for number 2, if you take a look, there was nothing out here next to the equal sign. That's the difference between changing the pattern and not changing the pattern. This pattern does not need to change because we're not stretching, compressing, or reflecting at all.